Okay, guys, let's go ahead and continue on with parts 2, 3, and 4. Questions 25 to 32 are worth 2 points each. Questions 33 to 36 are worth 4 points each. And the last question, number 37, is worth 6 points each. So, first one, 2-pointer, says if g of x equals negative 4x squared minus 3x plus 2, determine g of negative 2. So you just want to plug negative 2 in. So g of negative 2 is going to equal negative 4 times. Now remember, anytime you plug in a number for a variable, you want to put it in a parentheses. So it's negative 2 squared minus 3 times negative 2 plus 2. So what you could actually do is take your calculator on this, and I checked on the answer keys to make sure this was legit, and you can plug it in exactly as you wrote it here after the equal sign. So it's going to be negative 4 times negative 2 in parentheses, exactly as you see it now, parentheses and all, minus 3 negative 2 plus 2. And you get negative 8. So g negative 2 equals negative 8. 26. The student is in the process of solving an equation. The original equation is the first step are shown below. So here's the original, here's step 1. Which property did the student use for the first step? Explain why the property is correct. So two things, what is it and why? So if you look, the difference is they took the 7 and the 5a and they switched it. Okay, so they moved this minus 5a down to here and then the 7 over here. So that is the commutative property. And why is it? Because they rearranged the order of the minus 5a and positive 7. Okay? Moving on. 27. On the set of axes below, graph the line whose equation is 2y equals negative 3x minus 2. So over here, you want to get y by itself. So to get y by itself, you divide everything by 2. Y's cancel. So y equals negative 3 halves x. And then negative 2 over 2 is just going to be a 1, so minus 1. A couple ways to do this. Let's go ahead and use the graphing calculator. So you can type in negative 3 halves x. So remember, for the negative 3 halves, on the TI-84s, you can go alpha y equals to plug in a fraction, that n over d. And it's negative 3, 2, go over to x, minus 1. Second graph, get an XY chart. Okay, and you always want to just copy down the whole numbers on the XY chart. So let's do at least 3 or 4. Let's start at negative 4 there. So XY. And we have at negative 4, you'll be at 5. At negative 2, you'll be at 2. Okay. At 0, you'll be at negative 1. At 2, you'll be at negative 4. Let's do a couple more. 4, you'll be at negative 7. Okay, it gives us a good indication of points. So at negative 4, you'll be at 5. Let's go ahead and quickly label this. It's always good to label it. You got a lot of time for this exam. 3 hours. Remember, the positives are up and to the right. Negatives are to the left and down. So our first point is going to be at negative 4, 5. So here's negative 4, 5. Next point, negative 2, 2. So negative 2, 2. 0, negative 1. 2, negative 4. 4, negative 7. And then we're going to take a straight edge, ruler, protractor, whatever you got. Right now, I don't have that in front of me. So here's what we got so far. Probably was a little bit off the screen. I apologize. So I'm just going to take a straight edge and go graph this. I just folded up a sheet of paper real fast. That's what I get for not bringing the rulers home. Best you can, line up those points. Okay. Put arrows at the end. Make sure you get the arrows at the end, guys. Label it. This is, you can label it with the original or with the new one. You can say y equals negative 3 over 2 x minus 1. That's that line. And then on the bottom it has the equation. The linear equation contains the point 2k. State the value of k. So where x is 2, what is y going to be essentially? So when x is 2, y is going to be at negative 4. So k equals negative 4. Okay, 28. Looks difficult, but you know, these are definitely doable. Remember the tricks that I taught you. Says the formula A equals V of f minus v of I over t is used to calculate acceleration as a change of velocity over a period of time. Solve the formula for the final velocity, so you want to get this by itself, in terms of the initial velocity, acceleration a, and time t. So here's our original. Okay, A equals v of f minus v of I over t. And you want to get right here, this guy by itself. So this is v of f minus v of I over t means you're dividing by t. So what's the opposite of dividing? Is multiplying. So if you multiply both sides by t, these t's cancel, and t times a is just at or ta, doesn't matter. We'll do a times t or at, okay? And what do you have left is going to be the v of f minus v of I. So we want to get v of f by itself. So how do we get rid of the minus v of I? Add it to both sides. So you're going to be left with a times t, just rewriting, plus the vi, can't combine anything, equals your v of f. That is your answer. (29) says solve for x, that inequality. So a few ways we can do it here. You can notice that the 3/5 is smaller than the 4/5, so you won't get a negative if you bring the x's to the right. And I think I'm going to start by doing it that way. So we're going to subtract 3/5 x on both sides. Remember, this is our line, our wall, okay? So when you subtract the 3/5 x here, these cancel and you're left with the 1/3. 4/5 minus 3/5 is 1/5 x minus 1/3. So since I brought the x's to the right, I want all the other stuff to the left, and we start with getting rid of the minus 1/3 by adding 1/3 to both sides. 1/3 plus 1/3 is 2/3. 1/5 x drops. Okay. So now we get left with one more thing. How do you get rid of the 1/5? divide by 1/5, or you can multiply both sides by 5, because when you do that, this will cancel. But let's go ahead and just divide by 1/5 and let the calculator do the work. Okay, so the 1/5s cancel, x, we got the less than sign, and let's go ahead and grab our calculator. Clear everything out. So it's going to be 2/3 divided by 1/5. So alpha y equals, let's put 2/3 in. Divide, another fraction, 1/5. Enter, and you get 10/3. And that is your answer. Okay, continue to move on. It says, is the product of two irrational numbers always rational? Justify your answer. Okay, this comes from the very beginning lessons when we were doing properties, and then we also include irrational and rational numbers. So remember, irrational is a number that goes on forever without repeating, okay, or no pattern. An irrational number is a number that terminates or is a repeating decimal. Okay, so what I can think of is square root of 2 is irrational. Okay, so why is the square root of 2 irrational? A lot of square roots are irrational. So if you go second x squared to get your square roots and 2. Okay, square root of 2, when you plug it in, it's 1.414213562 and so on. So that's definitely irrational. It goes on forever without repeating. Okay, so if we took the square root of 2, which is irrational, and multiply it by the square root of 2, you get the square root of 4. The square root of 4 is exactly a plus or a minus 2, and that is a rational number. So we have irrational times an irrational, and our result is rational. So is this statement true? The product of two irrational numbers is always irrational? No, it is not always, because of the above proof. Okay? And you know, you labeled irrational times irrational gave us a rational number. 31. Solve 6x squared minus 42 equals 0 for the exact values of x. Okay, no problem. Let's do it. I want to get x by itself. So we do that by adding 42 to both sides. And we get 6x squared equals 42. Divide by 6. X squared equals 7. How do you get it squared? The opposite of squaring something is square rooting it. So x equals a plus or a minus square root of 7. And that one's done. Okay, let's move on. There we go, a piecewise function. Okay, it says graph the function h of x, 2x minus 3, where x is less than 0, and x squared minus 4x minus 5, between 0 and 5. So a few things here with our piecewise function, and gave us a domain to where to graph. So this one, you want to go less than 0, not further than 0. Okay. And this one, you only want to graph between 0 and 5 on this graph. So first thing is, we're going to label the graph real fast. Okay. Labeling, I know it stinks. You guys don't like it, but you got to do it. It'll help you when you starting to graph these. So 0 through 10, positives always on the right and up. The other one, negatives, which is to the left and down. Okay, so I'm thinking while I'm doing this is I want to do XY charts for both. So we're going to go ahead and do a 2x minus 3 over here. Get an XY chart. And for the x's, we want 0 and below. So we want 0, -1, -2, -3, -4, -5, and so on. Okay. And then over here, for the x squared minus 4x minus 5, we want between 0 and 5 only for the x's. 0, 1, 2, 3, 4, 5. And a few things I want to remind myself with is that since there's no line underneath the inequality, this is going to give me an open dot when I graph it. And then over here, oh, I should say an open dot at 0 when I graph. And over here, since I have lines underneath, those will be solid dots. Okay, so let's go ahead and start with the y equals. And we got 2x minus 3. I like doing this one at a time, guys. It's just easier to look at the graph. So 2x minus 3, second graph. And remember, I want nothing greater than 0. So at 0, you're at -3. At -1, we're at -5. At -2, -7. Then we're at -9. So you can see the pattern goes by 2. So this will be -11, -13, and that the rest won't really fit on the graph. So I'm not worried about the 6, but we'll just put it down. All right. So at 0, -3, we want an open dot. Here's my open dot. Then -1, -5. You could have the solid dots now because it's part of it. -2, -7, -3, -9. Okay, when I graph it, I'm allowed to have an arrow go at, sorry, probably off the screen. I'm allowed to have an arrow going down. Remember, you want to use a straight edge. And I could have an arrow going down because it's just less than 0. So it does go on forever, but only in the one direction. Okay, the other one, let's go ahead and graph the other guy. So y equals, clear that out. We're at x squared minus 4x minus 5, second graph. We only want between 0 and 5. So at 0, we're at -5. At 1, we're at -8. At 2, we're at -9. At 3, we're at -8. At 4, we're at -5. And at 5, we are at 0. So we have solid dots. So 0, -5 is right here. 1, -8. 2, -9. 3, -8. 4, -5. And 5, 0. No arrows with this because we only want between 0 and 5. And we're done. So we should have something that looks like that. Sorry if I was off the screen on that one, but with these it's hard to get everything going on the same screen. Alright, 33. There we go. We're going to graph some inequalities. We do this the same way. Remember, y has to be by itself. So I'm going to take each one of these inequalities, and I'm going to take, let's say, this one to the left. We got 2x plus y greater than or equal to 8. Then over here we have y minus 5 less than 3x. Y's got to be by themselves for both. So for this one, you subtract the 2x on both sides. And we have y greater than or equal to, I like putting the x's first, so the minus 2x, and that's a positive 8. And over here, we just add 5 to both sides. And we have y less than 3x plus 5. Remember, you can't combine these because they're different terms. One has an x attached, the other one doesn't. Same on the other side. Okay, now I also want to start with, again, labeling my graph. I can hear you guys complaining already. Okay, you guys don't like to spend the time to label, but you got a ton of time on this test, 3 hours. Okay, and when you label, it's just a lot easier to start graphing things and keep counting squares. I'm going down with the negatives. Okay, so we're going to start getting our XY charts. So let's start with the first one. Go ahead and plug it in. We got negative 2x plus 8. And we have a greater than or equal to sign. So again, you want to take your calculator, go all the way to the left where the slash mark is. And you want a triangle that represents a greater than sign, which means you keep hitting enter, or if you have the TID for this addition, you want to go over to where it says line, and there's a triangle that shows greater than because it points to the right. See how that points to the right? This one points up and to the right. So go ahead and hit OK. But we need our XY chart first before we start graphing it. So second graph. And we want to stay on the graph, and since we have tens, we don't want anything bigger than tens. So we got negative 1, 10, 0, 8. What's the other ones here? 1, 6, 2, 4. Okay, since I see I'm going down by 2s, we're going to have 3, 2, 4, 0. 5, negative 2, 6, negative 4, 7, negative 6, and so on. Might not go a little bit further. You got the room, might as well do it. Okay, so negative 1, 10 is up here. 0, 8, 1, 6, so on. I'm just going to go ahead and keep plotting the points. You can see where the line is going to be. And I want to remind myself, since I have a line underneath this one, that's going to be a solid line. The one that does not have the line underneath is going to be a dotted line, but this one's solid, so that's what I'm going to graph. And then I'm going to go to my calculator and hit the graph button and find out which way I'm going to shade. So in this case, I'm shading up. lines best I can, just like this. Don't forget your arrows, because it does go on forever. Alright, and we can label it y greater than or equal to negative 2x plus 8. Next one, y equals, clear that out. You want a triangle that points the other way now, so go over to the slash mark, hit enter. There it is. You want a triangle, there it is, points the other way. Go down OK. Go over 3x plus 5. Press second graph to get our XY chart. Remember, we got nothing bigger than the tens. So we're at negative 5, negative 10, negative 4, negative 7. So it's going to go by 3s, I see. Negative 2, negative 1, 0, 5. Did I skip one? I think I did. Negative 1, 2, 0, 5, 1, 8. And the other one's a little bit too big. So negative 5, 10. Negative 5, negative 10 I should say, is down here. Negative 4, negative 7 is here. Probably can't see it, I'm sorry. Negative 3, negative 4. Negative 2, negative 1. Negative 1, negative 2. Sorry, negative 1, positive 2. 0, 5. 1, 8. And don't forget, I reminded myself this is going to be a dotted line. Take my straight edge. Make sure I show a nice dotted line. Arrows at the end. Just my dotted line. Arrows at the end. Then I'm going to hit the graph button to see which way I'm shading. And I'm shading down from the line. All the way through the graph. Remember, the checkered area that we have now is all the solutions. And it says determine if 1/8 is a solution set. Explain your answer. So 1/8, if you look, 1/8 is on the dotted line. Okay? Since 1/8 is on the dotted line, it is not. Dotted line represents that this shades all the way close to it, except for actually on the line. So no, 1/8 is on the dotted line, representing a non-shaded area. Okay, so that is graphing inequalities. A good reminder. That's a 4-point question, so you're going to be a little bit harder. It is more points the harder the question. Okay, moving on. 34. So on the day Alexander was born, his father invested $5,000 in an account with 1.2% annual growth rate. Write a function, a of t, that represents the value of the investment t years after Alexander's birth. So there's a few things here. You have to remember the equations for growth, decay, or appreciation, depreciation. I can even say it there. So the two equations are very similar. Okay, if things are going to go up and you're going to get more money, then it's going to appreciate in value. So let's just go ahead and we're going to write it down here, the formulas. It's the initial times 1 plus the percent to the time. Okay, and this is for appreciation. Okay, the other one, depreciation, is going to the initial times 1 minus the percent to the time. Remember that the percent has to be a decimal. Okay. So in this case, we are an investment with a growth rate. Okay, which means it's going to appreciate in value. And the 1.2% is a decimal. If you don't know how to put this into a decimal, just put it over 100. So 1.2 over 100 is actually 0.012. Okay, or if you take your calculator and you do 1.2 divided by 100, that's where you get the 0.012. So the equation that they want, or function, A of t, is going to be 5,000, so your initial, times 1 plus, this has the decimal, which is 0.012 to the time, t. Okay? So since we have that, they want to know, determine to the nearest dollar how much more the investment will be worth when Alexander turns 32 than when he turns 17. So this is our times now. We're going to have to do two of these equations. So we're going to have A of 32 equals 5,000 times 1 plus 0.012 to the 32nd power. And then we're also going to have A of 17, which equals 5,000 times 1 plus 0.012 to the 17th power. Alright, so we're going to type this part in the calculator. We have 5,000 times 1 plus 0.012 to the 32nd power, which is to the nearest dollar, it says. So we'll go with cents and then we'll round at the end. 7323.9. We'll round to the nearest cent right now. 97. Okay, and the other one, 5,000 times 1 plus 0.012 to the 17th. That one is 6124.05. So when you subtract those two, 7323.97 minus 6124.05, you get $1,199.92. So when you round it to the nearest dollar, you're going to get approximately $1,200. Okay. A few more, guys. We're getting there. There we go. It says Stephen collected data from a travel website. The data included a hotel distance from Times Square in Manhattan and the cost of a room for 1 weekend in August. The table containing the data appears below. So we got the distance from Times Square and the cost of the room. So it looks like the closer it is to Times Square, the more it's going to be. Okay? Now we got to write a linear regression equation for the set of data, round all values to the nearest hundredth. So in order to do that, I want to make sure of a few things here. All right, when I go to mode in our calculator, we're going to take the diagnostics, we're going to turn them on, because that's going to give us our coefficient on top of our linear regression. Okay, so you go down, hit on, quit out of there, and then we're going to go to stat. We're going to edit. If there's anything in there, clear it out. And line 1 is going to be our x. So we're going to plug all those in. We got 0, another 0, 2 1s, a 3, a 4, a 7, an 11, a 14, and a 19. Our line 2 is going to be the cost of the room, so we're going to plug those in. 293, 263, 244, 224, 185, 170, 219, 153, 136, 111. Okay, I'm going to make sure they line up, and they do. They look like they are all accurate. And now we're going to go back to stat, go to calculate, and since it's a linear regression, we're going to hit number 4. Go down to calculate. So we have from y equals, we got some information here. We got from y equals a of x plus b. We have a equals, it says round to the nearest hundredth, negative 7 point, so here that 6 is going to tell us to round that to a 6. And our b is going to be 246, and the 8 tells the 3 at the end there to round it to a 4. So it says write a linear regression equation. So we're going to have, just plug in a and b. Y equals negative 7.76x plus 246.34. Okay? It says state the correlation coefficient for this data set to the nearest hundredth. So when you look at this, the coefficient is the r, not the r squared. So it says our r equals to the nearest hundredth is going to be negative 0.8. That 6 tells it 7 to round to the 8. So negative 0.88. Okay? Explain what the sign of the correlation coefficient suggests in the context of the problem. So our sign is negative. So since it's negative, it suggests a negative correlation. So we got that part in the context of the problem, which means the closer you go to time square, the more the cost will be. Okay? So, and then obviously the further you go, the less it will be. So as your time, or sorry, as your distance goes up, your cost goes down. You can even do that one. You can even write that one if you want. As the distance from time square increases, the cost decreases. Okay, either one. You don't have to put them both. Okay. Moving on. 36. Let's see what we got here. It says a snowstorm started at midnight. For the first 4 hours, it snowed an average rate of 1/2 inch per hour. The storm then started to fall at an average rate of 1 inch per hour for the next 6 hours. Then it stopped snowing for 3 hours. Then it started snowing again on an average rate for 1/2 inch per hour for the next 4 hours until the storm was over. On the set of axes below, graph the amount of snow accumulated over the time interval of the storm. So let's go ahead. It says for the first 4 hours, it snowed an average rate of 1/2 inch per hour. All right, so this is the accumulated snow on the y-axis here. Here is the elapsed time. So in hour 1, it went 1/2 inch. In hour 2, went up another 1/2 inch. Hour 3, another 1/2 inch. Hour 4, another 1/2 inch. So we can stop there and see what. Then it said for the next 6 hours, it did an average rate of 1 inch per hour. So on hour 5, it went up an inch. Then it went up for the next 6 hours. It did this. So this was 1. Another hour, that's 2. Another hour, 3 hours. 4 hours. 5 hours. 6 hours. Okay. Then I said it stopped snowing for 3. So 1, 2, 3. So far we're having 8 inches on the ground. And then it starts snowing again at 1/2 inch per hour for the next 4 hours. So 1/2 inch is 1 block. So for 1 hour, for 2 hours, for 3 hours, for 4 hours. So when we graph this, we're going to use a straight edge. There we are. Make sure you're at 0. You're in the corner there. Then we're going to be from here down. Then we're going to be straight across. And then again this way. Alright, so that's what it looks like. And then it says determine the average rate of snowfall over the length of the storm. State the rate to the nearest hundredth per an inch per hour. So that's basically from when it started to when it ended. Okay, so it started at 0, 0. 0 inches on the ground at 0 time. It ended at 17:10. So we have 0, 0, 17:10, x1, y1, x2, y2. So the average rate of change is the slope. So it's going to be 10 minus 0 over 17 minus 0. Okay, remember the slope formula, y2 minus y1 over x2 minus x1. So that's what I'm substituting in. Okay, my y2, there it is, it's 10. My y1 is 0. So essentially it's 10 over 17. So in the calculator, 10 divided by 17. And I get 0.588. It says round to the nearest hundredth. So that's 0.59 inches per hour. Okay, make sure you label inches per hour there. Alright. Moving on. Last question. It says Alyssa spent $35 to purchase 12 chickens. She bought 2 different types of chickens. American chickens cost $3.75 each, and Delaware chickens cost $2.50 each. Write a system of equations that can be used to determine the number of American chickens A and the number of Delaware chickens D she purchased. Alright, so if she spent $35 to purchase 12 chickens, that means she had the American chickens plus the Delaware chickens, and she got 12 of them. We know that the American chickens cost $3.75 each. That's for the Americans. And the Delaware chickens cost $2.50 each. And she spent a total of $35. So remember